All right, Scalable UI. Oh, does this work? Yeah, all right. All right, Scalable UI. It's a thing. First, I want to give you some background. Started a company called Vigor 4 years ago almost, and we built connected video applications. So, to give you a bit of an impression, this is a app. And what's special about it is that we try to extend the UI from the phone to a TV and try to make one UI which spans across devices. All right. So this was pretty hard to actually get to work, especially since we work for large media companies, because they tend to have lots of users. They want to be on many platforms, like Netflix. We had to do many different integrations. Data had to be real time, because obviously you cannot really show the connectivity. We had to provide native UI experiences, and we tried to do it with JavaScript, which was harder than we expected before we started with this. So what we did to solve these problems was actually building a new stack. So yeah, it's a bit wild. And that stack is called Scalable UI, the UI-driven stack. All right. So this very complicated graph that we have here kind of shows what we faced. Like after years of research, this is what we came up with. So on one axis you have platforms, which makes it harder and harder the more you add, because you're going to add Android developers, iOS developers, Roku developers, et cetera, and the more different code bases you get, the more diffused your app is going to be, and the harder it's going to become to keep up and change fast, especially that. And then of course you have users on the other side, which our friends of now are helping us deal with quite nicely now. The more users you get, the more time you're going to spend on dealing with infrastructure and DevOps. So these two things lead to difficulties. All right. So the stack that we built consists of 5 big components, essentially. Most of them are not really ready to be used yet, but I will talk a bit about them. So the first one is Brisky. So what this essentially is, it transpiles stateless JSX components into subscriptions straight on the data. So we tried this approach versus React because we had to have native performance on relatively slow devices. So yeah, and we didn't want to go for hybrid apps, because hybrid apps is essentially the same thing as native apps. You end up with a bunch of native code and it becomes unmaintainable really, really fast. So we really wanted to have JavaScript everywhere, since most platforms support JavaScript. All right, so why not React? This is pretty controversial, what I'm going to say right now. For us it was really too slow, because we had to support old smart TVs, we had to support Chromecasts, but with apps running inside the Chromecast itself, so not as only a receiver. We had to support Fire Stick TV, which is really, I really don't like it. So for example, Netflix deals with this problem on smart TVs by building a proprietary framework called Gibbon, which essentially compiles apps into some weird, I don't even know what kind of code. And we didn't want that either, because it creates too much friction between your code and where it actually runs. So this is a small, I decided to not go for graphs, but I decided to go for a Windows screensaver. This is built using our tree diffing algorithm, and these are 8,000 individual dots doing 16K updates per frame. And it's all, yeah, it's all based on a tree. So it is running on a MacBook Pro. And most of our benchmarks, we are 30 times faster for everything, essentially, than React. Always 4 times lower memory consumption, at least. But that's an easy one, smaller bundle size, which is more important than you would expect. I have a now link, let's see if it works. Oh. Internet would be nice. All right, well. All right, so how does this work? Oh. Why does this become so fast? It's because we don't use virtual DOM trees. We decided that data is always going to drive the change and always going to drive the updates on every piece in the stack. So we do all our diffing algorithms on the actual data and let the UI flow from there. And that's actually what I want to demonstrate today, that that's a good way to go. Since you essentially save a lot of extra data because you're already having the data in memory, you're already dealing with change there. So yeah, that's, all right, so that's Brisky, transpiles JSX components into subscriptions on data. All right. Another thing that we are developing, and this is still really under active development, so not quite ready yet, but we're using it. It's called BuilderBoy, and what this does, it's essentially a build tool that does static analysis on your code and creates builds based on user agent. So yes, user agent, pretty, again, controversial move that we made here. The reason that we needed this is that responsive design, like responsive CSS, doesn't really work if you want to make a native app and a phone web app, for example. Like a TV UI is fundamentally different than a phone UI. And it's so different that you need more than CSS. You need to be able to distinguish between those two. So let me show you how this looks, the system that we came up with. We have a few variables that we derive from a user agent, like device. And if you see that the device is a TV, this will render a TV app, and else it will render the rest. Can you see this? All right. So this is a very simple approach, and again, this allows developers to unify their app development. So even saying, all right, we're going to use JavaScript everywhere is not enough to unify that flow. So now you can reuse components really easily. You have one entry point. If you add 20 more platforms, it's fine because it's all supported from this. Yeah, as a few extra bonuses, it removes that code for platforms that don't need certain types of code. It allows you to pre-render completely differently for different devices, just going to the same entry point, because we know that you're coming with a phone because we check the user agent. And we have a special bundle based for phone. So yeah, again the question, why didn't you use Rollup or Webpack or whatever? This was actually a really, really difficult problem to solve because if you branch your builds like this, you quite often end up with around 100 builds or 200 builds. And we didn't want to lose the connection when you're developing, that you're actually developing the code that's going to run on production, and that you only do this as some kind of post-parsing activity. So it was speed. So this BuilderBoy thing creates builds within 5 milliseconds. I will demonstrate in a bit. And this is an illustration of something that we use it for. This always gives your CSS the perfect prefix for a user agent that you end up with. And this one little file already ends up in 30 different builds. So you can imagine if you add some more combinations, it will grow pretty fast. All right. Ploy is another tool that we have. It's also not open source yet because still under active development. What this does, it essentially allows you to deploy to a lot of different platforms that allows you to wrap JavaScript. So here's an example how you can use it. So you see this ploy field in the package.json, and put some information in there, like the app name, the bundle ID, device, version. Then you need to set up some environment variables for your Apple username and password. So that, I don't know if that's good enough yet, but and from there, if you type ploy, it will create a build, set up the certificates, and put it online, put it on a now instance actually, in an enterprise build. So you can see the code there now, which creates the URL of a repository or folder, and then you can pipe it to Ploy, and Ploy will create a new now URL, which are actually the native app. All right, well now you probably know this tool. It's the only thing we didn't build in this stack, so it's really nice. It's a really important part of this stack, and we actually experimented with similar ideas before we moved to now, but all based on HA proxy and ring pop and very difficult things, hyperbound from Uber. I don't know if anyone knows this. So this was much easier, and this saved us a lot of work, so we could actually focus on doing UI, which we like. And what makes now a really, really good fit is that it's a UI-first infrastructure platform. And the reason why I'm saying that is that you all probably know the freezing mechanism of now, right? So a bit annoying sometimes because your app, your website seems down. But that part of the model really fits this, because if I deploy every iteration of my project, of my front end, with a plethora of services and microservices, you want a model that allows that allows for that and doesn't raise your bill of Amazon like crazy, or needs someone to manually disable all the servers and stuff like that. Also, when you're dealing with different versions and native applications, you can end up in a situation where native wrapper points and needs an older application, including infrastructure. Yeah, so if you can point to an older application without having servers running for that and auto-scaling that, this really works for us. So, okay. We built one tool on top of it. We couldn't resist. It's called Now Services. And this, again, is a very small thing in a package.json. So what you see here is that I can add services as dependencies in my project, because if you build a big media app, you end up with many microservices, like can go as well, at least 20. It's not so weird, right? So this way, I can actually make services that have other services as dependencies, and other services can also be NPM dependencies. So in this case, it's a pretty simple example. I have a hub, and this is something I will talk about a lot today. I have a JSON server, and I have an image resize server, which points to an NPM module. Each of these services can have other services again as dependencies. So yeah, this is a little thing that we added, but in general, we follow the Now model pretty strictly. All right, Hub.js, this is actually what I'm going to talk about today. The rest was just to give you an idea where this fits. So, well, this is the GitHub URL. We're open sourcing this today, so this is actually a pretty big thing for us. And put a beautiful quote: "Screen is nothing more than a window into the cloud." Well, that's what we're trying to facilitate with the hub. All right, so I want to start with what it's not. So it's not a database, it's not a query language, and it's not persistent storage. So that it's not that. All right. What is it? It's a single state shared across clients seamlessly. And this is not a new thing. You can see a bit of code here where I connect to WebSocket server. I subscribe. In my subscription, I subscribe to any title that updates. So I think this code must seem familiar, like, or something similar like this exists. And then I log and I get an update in the callback for every entry that has a title, in this case. Right, but it has some extra features. This is the most basic. It can be a client, it can be a server. It can also be both at the same time. So you can use it as sort of a pipeline or a transformation within your stack. It can run in the browser. It allows branching of data. This is a concept that we'll go into with a demo because it's hard to explain. It supports observable references over the network. So you can, ideas that you can use references a bit like you would use them in normal JavaScript, but they're serializable and observable. It stays connected, which is a harder problem than you would expect with flaky connections, 3G, etc. Conflict resolution is baked in. So if I go offline and I type something on a field, and I come back online and someone else wrote to that field in the same time, we'll actually resolve the two things based on a timestamp, and that's, you have to offset the timestamp over all the machines, and you get into very weird, yeah, it's strange, but that's already in there. You can write functions as queries in a subscription that can be sent to a server. They can be whitelisted for security, but I'm not going too deep into that. It facilitates microservices model by chaining multiple hubs. So that's why it's important that a hub can be a client and a server at the same time, because you can be a client to a hub that does some recommendation processing or image processing or whatever without taking the load. And this is probably the most important. it's very high performant. And we needed this because we actually use it to drive our UIs. We only use the hub to drive the whole UI. Right, so very complicated picture again. This is our model. Don't know how to call it. It's a client. It gets updates automatically from the hub. Usually it only has to send a hash of the subscription that it has itself. So it's just very small request, and from that moment it's in sync. And the hub will pull a database or use Firebase or whatever for its persistence layer. It can also be Redis, that's what we use. All right, so a lot of words. And now I would like to show you some actual code. This is readable? All right. Okay, I need to start this. So I'm going to start simple. I need to start the hub. All right. I'm using the Tumblr API, but it was down today. Okay, it's good. So let me start with what the hub is. So you see this project repository, and it uses a services field, which points to the hub, which I showed earlier. And the hub is in this folder right here, which is essentially my backend. You can see it like that, or my data store. And I integrated Tumblr for this app. So here I use a node fetch, get the API using an offset, create an object of the posts where I fill in source, title, and subtitle. And then I use a generator function in the hub which gets the first 100 pages, which is maybe a bit much. Well, all right. Let me get the first 2 pages, probably a bit more normal. All right, there we go. All right, so this is a bit less. Good. So this little app doesn't use any UI framework. It also doesn't use JSX. It's only a subscription on the hub, and from the subscription we use vanilla JavaScript to create these elements. So I hope that everyone still knows what document create element is, but that's what I'm going to use. That's my framework of choice today. All right, so simple. Import the hub, add a handle on the window so we can do some stuff in the console at log. Subscribe to each photo, which we just filled in here, right? Photos. And then I get a callback, and I get 1 callback for each update. This callback gives me a few things. Gives me a data, which is a container object of the actual data that I'm receiving. Gives me a type, which is very important to do stuff, which can be new, update, or remove. Gives me the subscription that spawned it, which is not very important today, and it gives me the tree. And I'm actually going to use the tree to do some UI stuff. Right, so on type new, what I'm doing, and bear with me now, this is document create element div. So these are these little square holders. Put an image in there, a title and a subtitle, and we can type in the subtitle. Right, so here I'm using a feature or a method on the hub itself, which is called get. What this does, essentially you fill in a field, and you can use this if fields do not exist yet, because everything is asynchronous and everything is over the network. You cannot really assume that you have data, or at least it's a way of programming that we like. So this now puts a default here in the get, so if the source is not there, it will do an empty string. We could also do something else, blah, 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 I know, whatever. All right, so after that you see compute. We use compute because you can add transform properties on the data model. That's an extra little feature that we added because it allows you to, for example, if you have multiple languages, you can put a transform based on user language and choose the correct language that you want to see without, going too wild. Borrowed this a bit from functional programming, but it's a method, so yeah. All right, put the title here using inner HTML, dangerous. Value in the input field. and this is complicated. I add an event listener input on subtitle, which will set the data set subtitle to the subtitle value. So this allows me to type, and hopefully it's synced, right? Because everything's automatically synced. Okay, so that's the new part of this incredible app that you see here. And we have the update type, and on update, I only want to update because I know that we already created the elements that are there because it's an update type of the subscription. I can apply just an update to the fields. So usually what we do in Brisky, when we make the transpiler, we actually have the exact updates for every field, which results in the fastest possible result because you only touch the DOM where it's absolutely necessary. But for simplicity's sake, I wanted to just do it simple today. Right, and then you have remove, which removes, if an element gets removed, it removes it from the DOM. And then there's one little funny thing that I didn't touch yet, which is tree.node. So tree is a arbitrary storage that we use. It's our diffing tree for the data, but I can store any other field on this. So here I just decided, right, node is going to be a thing. And now we have a tree that actually holds the diffs as well. So it's easy to retrieve the correct diff when an update happens after it's created on the data. And here I remove it using delete. All right, there's a small little thing. Here you can connect process.env is something that we add with the services field, which is the name of the package of the service you want to connect to, but in capitals, and dashes are not supported, so they get rewritten as well. Yeah, and if that's not there, we're going to connect to localhost 33. All right, so pretty simple app, I think this is doable. So what I want to add now, I want to go a bit wilder. I want to add more data, and I want to add scrolling, that it has infinite scrolling, because it's important. So, all right. Run scroll. Okay, so I added a favorite icon as well, because why not? Here we go in the code. Actually, the only thing that's different is here we're adding some listeners. So I'm adding a listener on scroll and syncing scroll top to the hub. Adding a listener to resize, setting inner width and inner height of hub.client. So this allows you to have a shared state of all the data, but you can go a bit specific for your own client. So you can use your own client's information in a subscription on the server. All right, so here I set inner width and inner height. This will now listen and update this on the server. And I set the initial one for when you're not listening. So that's why it's copied, essentially. All right, so that's the information that I want to use to start determining how many things I can display in this list right here, yeah? So I don't know if you can see it, but as you can see, the scroll bar grows when I go down. Is that clear at all? And it becomes, it has less items when I go up, which is a bit of a weird thing, but this is the only code that I use for it. So on any subscription, which you just saw, I can put a modifier on, for example, the keys. This allows me to do key manipulations purely on the keys array. So that could be slice, filter, all that kind of stuff. So what we're doing here, I'm getting the scroll top, I'm getting the inner height, I'm getting the inner width of the client, and this all gets executed on the server as well. So the server will not send you more data than what you actually need to populate your UI. And this, again, fits into the model of scalable UI. Like the UI drives the amount of data that we actually need to see, and I don't want to go into hoops of handling the server. Like this should be done from the UI's perspective. All right, so here I have, I wanted to have columns just to illustrate that that's possible, right? Responsive design. So here, you know, when it's smaller than 600, it has one column, etc., etc. You do some calculations, and then I slice the amount of keys based on the minimum amount plus the scroll amount. Okay, so let me put in some more data because this is boring. So, all right, 2,000 items. I think that's okay. Let me see if I didn't bust the limit. All right. And now it's still loading from the API in Tumblr. So it may not be as smooth, but we're getting quite some data in here. All right, yeah. And this is using the render technique, and this is what I wanted to show you, that, you know, you don't need a virtual DOM to make a fast app, because the DOM, it's 2017, you know, it's not that slow anymore if you compare it to the 90s, yeah. All right, this goes on forever, but okay, I wanted to show one more little thing here. Okay, let me reload, go to the top. I want to show offline that actually works. So if I destroy the server, okay, so server crashed, something bad happened, we're offline. Now I'm going to favorite here and here. Can you see this star? All right, some favorite. Oh, wow. It's not really clear. Well, there's a star here on my side. That's too bad. Wait, maybe I can change the color. Where's that icon? Red. Oh, I turned off the server, of course. That will not work. Yeah. Okay. Okay, now it's clear, right? Okay. Now I can show this beautiful demo. Turn off the server, or the hub, so it will not get data if I reload. And choose this one, and choose this one. And, all right, let's go back fast. So if this reconnects, now everything's favorited. So it got 1 star from this one and 1 star from that one. And that's, right. It's a simple thing, but to make it was hard. Yeah, sure.
It's generally really hard, right? Like if you don't change the subtitle at the same time.
Yeah.
And one of them wins, I guess.
Yes. So it's based on time, but I offset the clocks. And I take ping into account, which is really, really horrible to do because, yeah.
Right, it's very hard. Right? It's an eventual consistency
Yes.
problem, right?
Yeah.
So do you also? So you don't do things in terms of transactions, like suppose.
Yeah, I do things in terms of transactions.
So if you, like in one frame, like you can do a lot of updates. And all of them get applied at once, or none. Or
well, actually, how it works internally is that every change into the system, every input is tagged with a stamp, which is a condensed timestamp, and every transaction is stored. So it's using that, right? And to offset the time, I try to add as little extra communication as possible to save battery life. So you don't want this heartbeat to constantly go on just to offset the time, because that's actually what's necessary if you want to do it perfect. But on every message, I send the offset and recalculate it. Right. So I try to sort of pack it into normal messages to still make it perform.
Very cool. So one thing you could also do, which I happen to have worked on before, is like if you have counters, you would like to keep the real count, and then you need to kind of merge on the server with a special function. You kind of did increment instead of setting the timer to like 10, you just incremented it. So if 2 people do it.
Yeah, that.
And it seems like this framework could support
yeah, you can
that
do
really
that
nicely.
easily,
Right? Yeah.
Because you can add. I didn't show that yet, but you can add listeners, data listeners. Everything is an observable, so everything supports data listeners as well. So you can put a data listener on a field in the server and actually do processing there. And that's what this is really for, that we do all the processing of front ends, or as much as we can, we offload it to the actual server, because that saves us speed a lot. Especially if you have to integrate, for example, we had this once, it was a horrible experience. We had to integrate 5 different analytics platforms, 3 different content management systems, and for user management they had 4 different systems, all in different languages. So it was really, really great. Right, and in this kind of situations you need a place where you still have the feel of the UI, but you're actually on a server because, right, you cannot really go around it. All right, so I have one more little demo. That's it, and then I'm done. Which is, because this is nice, but we're now on one user, which is not so nice, because everyone that will go to this app in this room, you know, we will favorite the same things, and we don't want that. So let me start it, and this is actually a demo I made. All right. Oh, what? Ah, okay, I have 3. Okay, so this here I'm actually showing the system which is branching the data, and I think this is the biggest different thing that this hub gives, because the rest all exist in some way, but I've never seen this before. So essentially what we're doing is we're creating a branching data model, and you can branch it very similar to GitHub, right? So you have a master branch, and you have feature branches. The only difference is that the master will automatically merge everything it can merge in real time to the feature branches, so you keep updates, but everything that you do on your feature branch will not go back to master ever. That's sort of the rules. So what I use the system for, now I logged into Gym, so I didn't add password or whatever, I just use a key. And if I do this, it will not update the star on the thing on the left, because I'm now actually on my user Gym, right? But if I remove this one, because this is driven from the master, it will update on Gym, because it inherits from the master file of the data. And if I go to Gym here, it will have this one on favorite, because I'm logged in as Gym, right? James, blah. You can also write some text. Mountains are nice. That's what I need here. And then if I go back to blah, right, you get mountains are nice because I'm logged into this user. This system actually goes a lot further because you can add authentication here, and this is what we use to log in our users. So how it would normally work is that you have a token, and then you have some authentication service which will run on the hub, on the server itself, which will respond on a user logging in, because on the hub you have these branches as well. So I can actually respond to a single user with a listener instead of handling it for everyone. But that's not really in the scope of this demo, I think. But that's how we use it internally. Well, and that's sort of it. Oh wait, I can deploy it as well. Let's do that. That would be nice. Run deploy. All right. Okay. Come on. All right, there we go. And this is actually deploying 2 services, right? So it's a server and a hub. Okay, please. Okay, there we go. All right, so now we can all use this app and favorite pictures of mountains. Yeah, and obviously what you just saw in here was a really simplified example. And what our front-end transpilation thing does, it essentially transpiles JSX to these plain vanilla JS things on a subscription. And that's it. Any questions? Or yeah? Yeah?
Would it, when they come back online, they would receive the messages that they missed?
Yeah.
Okay, so like I'm thinking RabbitMQ. Have you heard of that?
Yeah,
yeah.
I've used it
sort of
before.
would you still need that if you use this?
No, you don't. It's fast enough. So I used Nano Message before, which is like the next RabbitMQ or whatever.
Yeah.
It's faster. But with this, it's fast enough to run on large scale, so you don't really need the message queue anymore.
Okay.
And we actually use a very simple way to deal with that, and that's you can layer your hubs, right? So if you want to have some intra-hub communication, you can have hubs as client of another hub. So you can have 20 hubs going to another hub, which is at a higher level. So you can use a pyramid structure, but in general, we don't really need that in our app. So what we do is which is actually a hidden feature of now, but we use routing based on key, which allows us to say, right, a user, because we connect all these different devices, right? So the ping has to be really low if you want to make the UI look smooth. So we route straight based on a key to the same servers, to the same hubs. Then we use a persistence layer like Redis, which loads one key, which is the key of the user ID, which is the context essentially, so it all sort of fits together. And we only do the real-time communication for the clients that are connected to this individual user. We did make an app once where there was a voting system, and for a voting system we use like higher order hubs, right? So you have a hub which arranges the votes, which distributes the votes, and has other hubs as clients to it. What you can also do is, for example, if you have really large amounts of data, or whatever, I don't know, like billions of entries, because usually a hub can support up to 1 million objects, fairly simple in a small process. But if you have more than that, you can add keys, like for example, I have a key movies and shows. We do video apps, so and movies can go to a specific hub and shows can go to a specific hub. So this way you have a lot of flexibility in scaling what you need. So yeah, no, we didn't find any need for nano message or anything like that anymore.
Okay. And you mentioned Redis just now, but you also said a hub is not a data storage. So can you connect it to any arbitrary data storage?
Yeah, I can show you how it works. It's really simple, actually. All right, if you go to GitHub. Let me see where this is. Really nice branches. Source, no. Hub, all right. So this is an example of an integration with Redis. Oh, it has my key in here. Oops. Didn't plan to show this.
You should have changed that.
But, all right, I will change the key. Fuck it. So here, create a client for Redis. And here I'm dealing with listeners. So client is, this is just the Redis client. And here, where is it? Here we go. All right. So this function, we call it an injectable, which allows you to sort of flavor any piece of a hub or a hub itself. And what we do when a user enters or when a user is authorized, we load the data. We change the get context method, which you can override and extend, where we say, right, as soon as you retrieve context, which was like my username, then load the key, return the retrieved instance, and then, yeah, here we say, right, each field, every field in the hub itself is going to have a data listener with a key Redis, because we still want to add normal data listeners. It's maybe a bit too dense, but this is essentially the integration layer to Redis from a hub.
Okay, is this something that's in the open source as an example?
We're going to open source this. Oh yeah, I think we actually have a separate module for it, but we have to open source it.
Okay, great. Thank you. Thanks.
So it's like in 100 lines you can make an
amazing,
integration, because it's built to make integrations. That's why it's called the hub.
Right.
It's like sitting in between.
That's great.
Right.
Thanks.
Any other questions? Yeah.
Do you use some sort of windowing library in production? And did you like make it yourself?
Like what, windowing?
Windowing, so it would only render the stuff that's on the screen at one time.
We don't use it in production, but what we do use is what I showed with the endless scrolling example, which is essentially just a subscription driven by width and height of the client.
So wouldn't wouldn't the things that are off screen, if like, so say I scrolled down and I received data for those ones that were
Yeah.
above, would they still update?
Well, in this example that I gave, it does, but you can also limit the amounts that you see and actually make your own scroll bar, and that's what we do in production apps. So we implement our own scroll and actually recycle through the elements,
Okay.
right, in a similar way, because you can say, let's set a key focus index, that's actually what we use for this, or focus, and then say, right, everything around the focus, which is sort of, you know, when you move through the list, I want 5 on top and 5 on the bottom of that maximum, which just allows you to keep it smooth, right? You need to create some kind of barrier. So we use 0 windowing libraries for it. We just use a subscription, and why this is nice to actually control it yourself is that the server has this knowledge, right? So it's not only the updates that you're limiting the actual data that's being sent, because the server is doing the windowing, and that's, I think, really new what you can do with this stuff. So no libraries, just.
Thank you.
Any more? All right. Thanks a lot.